Welcome to the webinar on Introduction to Nastran. This is just a basic introduction to a Nastran for basically a mechanical, automobile, and aerospace graduates who are going to pitch into the industry. So I'll be going with the basics of Nastran, what is Nastran, what is the history, and all. So let's begin. So today's agenda. First thing, I'll be going to the history and applications of Nastran, where it started, who developed it. I'll be telling those details in this slide. And later, I'll be giving an introduction to finite element analysis and computer aided engineering, which is used everywhere in almost every industry nowadays. So then we'll go into the current trends in the simulation industry, which every company is following, and what are the challenges and how they are, what is the difference between the old and the current trends. Then we'll look into the software and its providers. So who are the leading companies which are providing this Nastran software and the licensing and the software and hardware requirement. Then we'll move on to role of Nastran in OEMs. So most of the OEMs will be using Nastran for the analysis of their products. So, so how Nastran is helping them in the industries. So that I'll be discussing in this. And later we'll go into the insight. We'll have an insight into Nastran what and all types of elements we use in this and how it looks and what is the program and how the program looks, what is the input file, what is the output files for the analysis. Then we'll move on to types of analysis that we can do in this Nastran. So in the industries to analyze the products, and we'll discuss a case study also on this Nastran. Then finally we'll go into the job roles. So how you can get into the industry by learning this software Nastran. So history. Coming to the history, it started in NASA. So this is the first space shuttle which was launched by NASA in 1960s. Okay, Nastran. Nastran is basically the full form is NASA Structural Analysis. NASA ST for structural, AN for analysis. So NASA were developing this space shuttle. So they plan to develop a software for solving their problems in developing process. So they were looking outside. So what and all are the tools available for which can help them. So they found out that the currently available tools are not helpful for them. So they decided to develop their own tool. So for that, they have given a contract to Computer Science Corporation, which is a leading software company in USA those times in 1960s. So they collaborated with NASA and then they started developing this. The architecture of this Nastran whole bunch of bundle is given by NASA scientists, and the programming everything is done by Computer Science Corporation. So this is just a Fortran program which includes 10 lakh lines of code. It's just a basic. It's a program, the huge program with 10 lakh lines of code. So with that, FEA. This is a theoretical analysis which we all have in graduation. There is a subject called finite element analysis, finite element methods, basically. So this is the theoretical approach of problem solving, and CAE this FEA is incorporated into software, so that changed into computer aided engineering. So from that time, which this Nastran was used by NASA, the computer aided engineering was pitched into the industry of simulation work. Then Let's come to the applications. So there are a lot of applications. First come to automotive. In automotive industry, every component in an automotive needs an analysis to check whether it can withstand the loads. Is it reliable? So what is the lifespan of that component? And then in the aerospace industry also, they'll be analyzing the structure of the aerospace with huge when it flies in the air. So there will be huge thrust provided by the turbines. So then heavy machineries. So in this industry also, there are many things to be analyzed in the starting development process, product development process. So then this software Nastran is helpful in all these industries to solve their problems by simulations. So in the marine industry, in medical industry, in electronics. So marine industry also, they have so many problems that can be solved by Nastran, like the maximum load that it can withstand. And in the medical, it's like the medical, there are many applications. In recent years, there are huge developments in the medical field. So, and in electronics, yeah, it is like every it is a booming industry. So in all these industries, Nastran is helpful and currently used by all these industries. Basically, it is like used in developing a small pushpin to the huge space jets. So everywhere, this Nastran and CAE applications are there, which by which industries are innovating the designs with less cost and effectively. So let's move on to the introduction to FEA and CAE. Finite element analysis. As I said, it's a basic finite element methods. It's a theoretical subject. It is basically reducing the infinite degrees of freedom domain to the finite countable degrees of freedom. And this is like it is done by solving partial differential equations, and that theoretical thing was embedded into softwares, and all the calculations were done by the supercomputers, and the results will be given. So that is what computer aided engineering comes. So in computer aided engineering, there are different fields. FEA is like structures, comes into the structural analysis. And CFD is basically computer fluid dynamics, computational fluid dynamics. So it comes into the fluids like aerodynamics. And then MBD is nothing but multi-body dynamics. So it deals with the dynamics of the vehicles in the running time. And then optimization is like we have a design, so we have to optimize the design with less, we have to decrease the weight of that component. So there this optimization comes in place. And then all these combined CAD, CAM and CAE, everything, this is the whole bundle. So this entire product development process is based on computer aided engineering. Nowadays in industries, everyone is following this CAE. And there are in industries, there are basically three domains: durability, noise, vibration and harness, and crash and safety. So we are talking about Nastran, right? So Nastran is helpful in durability and NVH. So for crash and safety, we have another tools which are very sophisticated in solving those crash and safety problems. So, so by using Nastran, we can solve durability analysis like fatigue life cycle analysis, structural analysis, linear and non-linear, etc. NVH is like vibrations, noise, vibration, and harshness. Almost all the automobile industries use this method to solve the to to produce the vehicles which are for the users user friendly environment inside the cabin. In the inside the car, if noise is coming which is coming from the outside, if it is heavy, the person sitting inside the vehicle may feel weird. So the noise coming outside of the vehicle to inside, this should be reduced. That is done by this noise, vibration, and harshness analysis. Crash and safety is nothing but vehicle crash, and safety is like seating, airbags, and this and all comes in crash and safety. So CAE is like basically four departments. So structural and durability. Next is dynamic and acoustics. Next is multi-body dynamics. Next, flow and thermal. So as I said, Nastran will be useful in structural and durability, dynamics and acoustics. So what are the recent trends? First of all, I'll tell you how in the olden days how they used to do, how people used to conduct the experiments to solve the problems in the development process. So they used to build a physical prototype as shown in this picture. Picture, animated picture. This is done by Chevrolet. It is like in the development phase of suspension. Basically, they have a rail, the wheels connected to.
Excuse me, sir. Sorry to interrupt you, sir. Sir, there is an disturbance at the back, sir. Make sure that the disturbance get resolved. Sir, I'm
Okay.
audible.
Yeah. Yes. Yes.
Yes, there's more disturbance at the back. Make
Now
sure.
it's fine.
Yeah, sir. Now it's fine, sir. You can just continue with the session. Sir. Sorry to disturb you.
Yeah. Okay. It is fine right now.
Yeah, it's fine, sir. You can just continue with the session, sir.
Yeah. Okay.
Thank you, sir.
Yeah. Yeah. These wheels are connected to the frame, and there is a pole here, so which draws a line on a piece of paper. So this rail moves through the wheels, so that this pole will displace. This is the final stage of development that they achieved a straight line, which we don't feel any bumps even if the vehicle is passing through the speed breakers. So in the initial stages, they have many these bumps in this curve, whatever it is drawing on the paper. So this is what they did in the earlier, and this is like testing a aeroplane in a wind tunnel. They built a prototype, and this is a wind tunnel in which it is placed, and the air is blown from the front, so that it is they'll be physically testing the model, and everything is manual calculations and physical prototypes, which is included in huge cost of making the prototypes, and more time involved in developing these prototypes. So this is what the people used to do in the olden days in development of vehicles or any product. So what is the current way? Our current situation, it is everything with the help of computers. So the prototypes are built in the softwares in the computers, and they are simulated in the whatever the physical simulations they used to do, the same scenario, the same conditions they'll incorporate in the software, and they'll be running the analysis to check the displacements or stresses or all the types of details we need. So that is called virtual prototyping and validating techniques. So every application, so if we take multi-body dynamics, there is a separate tool. So in industries, it will be like a separate tool. For every type of analysis, people will be using a particular tool. For CFD, one software. So for linear static, one software. If you take linear static, mostly Nastran people will be using. And if you take non-linear, Abacus comes into place. So these process is like cost effective, and it will take very less time in the development for the development of vehicles or any product for the companies. So and we have also like the designers who are designing the products, they have complete freedom to develop to develop whatever their ideas. So when compared to the physical prototyping, if it fails, we need to build one more prototype physically. So in this CAE, computer aided engineering, the scenario is like we'll be building the prototype in pre-processors. Like there are basically three types: pre-processor and analysis, and the third one is post-processing. Pre-processing is nothing but building the prototypes, like meshing the parts, meshing the vehicles, and building the vehicles in the pre-processing softwares like Hypermesh, ANSA. These are the two leading pre-processors in the industries. So then the results what we are getting here in simulations, whatever the computer simulations, the accuracy of these results will be nearly about 60 to 70% of the actual result. Whatever the physical prototypes which are tested, that is nearly equal to 90 to 100% will be the result accuracy. But in CAE simulations and computer aided simulations, the accuracy level drops, and there is a major problem in the currently, which every industry is facing. So, so companies are putting more time and effort in developing the softwares which can solve accurately and within less time. So these are the this is the current scenario in the industries nowadays. So I'll tell you the process of development process of a product in the industries. So first, it starts with the design of the product. First, it starts with the design of the product. So all the CAD engineers, they'll be developing the designing design in the tools like uh, Unigraphics, CATIA, ProE. Then the design will be going into the meshing team, FE modeling team. So there the people will be building the models with FE modeling, I mean meshing. Then the meshing will be given to the solver. Solver here, Nastran comes into place. In the solving section, Nastran will be solving the problem, and the results, it will give the results. So those results are taken to the post-processing softwares like Hyperview. If you take Hypermesh, post-processing is Hyperview. For Nastran, it is like a pattern. And after that, those results, if they are okay, if they are validated, then they'll release the design for the production. If not, they'll again change the design, and they repeat the whole process again. So this is the process which every company follows in product development. Coming to software and licensing, So there are two companies which are providing this Nastran package. So one is MSc Software, which is acquired by Hexagon now. The latest version is 2019.0. The name is MSc Nastran. MSc Software, this is a company which was marketing this Nastran from 1960s with collaborated with NASA. And NX Nastran belongs to Siemens. So which Siemens bought the Nastran code and it is developing its own software called NX Nastran. The latest version is 2020.1 in NX Nastran. This is a proprietary license. So the license which these companies are providing, software license, like we every company buys it, so there is no free license available. So companies have to buy it on a token based licensing. And coming to the hardware and software requirements, these are the this is supported. Nastran will be supported in Linux and Microsoft operating systems. So these are some details of the hardware and software requirements. So what are the other tools other than Nastran and MSc which are already there in the industry, which are competitors? We can say competitors of Nastran. So Altair Hyperworks, this is also a company which is having almost all the types of tools which can support all the types of analysis. ANSYS is also the same simulation company, simulation software. SimScale is the recent company, new company which came into the industry. MathWorks, it is like MATLAB. MATLAB will come into this MathWorks and Autodesk, Simulia, COMSOL, LS-DYNA. These are all the companies which are competing with Nastran, and they have all the capabilities which Nastran is having. So what is the role of Nastran in OEMs? Okay, OEM Nastran is like Nastran is widely used in the industries which the continuous development of products is possible. So if you take a automobile, there is a chance of continuous development process. And if you take an example of any box, any small tiffin box or something like that. So there is no much development goes into that lunch box. So there is only one design, it will be fixed. So on the analysis which needs to be done is only very limited. So in the case of in automotive aerospace and all, there are plenty of components, the huge number of components that are to be analyzed and which are to be validated and tested. So these are the companies: automotive, aerospace, marine, medical. These are the places where Nastran is very much helpful for the engineers. And it is like solving what are all the complex designs, the designers which are designing the basic designs can be solved easily, but the complex designs, for solving complex designs we need sophisticated software, sophisticated solvers to run the analysis and to solve millions of calculations in within less time. So here Nastran is helpful for the industries in solving within less time. There are different types of analysis which can be done by Nastran. There there will be correlation studies. Correlation is nothing but physical testing versus CAE simulation. There will be a comparison. between the physical testing and CAE simulations. Whatever the component which is tested in the test desk, so the same scenario it will be created in the software. So the results which are coming in the physical testing and the results which are coming in the computer aided simulation, they will be comparing those two values, those two results. And if it is the CAE result is near to the physical testing result, then the problem is validated. If not, the whatever the conditions they have prepared in the software, there might be changes. They might have not correctly modeled it. So that is where the correlation comes between physical testing and CAE analysis. So companies which are using this physical testing, they are migrating into computer-aided simulation based on these correlation studies. And for Nastran, there will for from MSc Nastran and NX Nastran, the companies will be providing support for all the engineers working in the companies. They have a support desk, whatever the problems they have regarding Nastran and the trainings. Those companies like MSc Nastran and Siemens will be providing.